Hello, in this lecture we will find the value of x using two different methods. In the drawing we have right triangle ABC and we know that angle BAD equals to alpha, angle DAE also equals to alpha, and angle EAC equals to alpha, and we also know that BD equals to 3 units, DE equals to 4 units. Again, angle ABD equals to 90 degrees, therefore triangle ABC is a right angle, and we want to find out the value of EC that is actually defined as x. Okay, so first of all I will present to you the angle bisector theorem. Actually, angle bisector theorem relates to a triangle if angle bisector, if we have triangle ABC the angle bisector AD divides angle BAC, divides this angle BAC to two equal angles. That is to say, this angle, if this angle is theta, this angle also will be equal to theta. So angle bisector AD divides angle BAC to two equal parts, to two equal angles, and actually the angle bisector theorem states that an angle bisector divides the side that it hits in a ratio that equal to the ratio of angle legs. I will read angle bisector theorem again. Angle bisector theorem states that an angle bisector divides the side that it hits in a ratio that equals to the ratio of the angle legs. Okay, so according to angle bisector theorem, the angle bisector AD divides the side that it hits, that is to say divides side BC in a ratio, that is to say the ratio that angle bisector AD divides side BC is actually BD over DC. That is the ratio that angle bisector AD divides side BC, and that ratio equals to the ratio of the angle legs, and the legs of the angle BAC is actually AB and AC, and the ratio between those angles is actually AB. Those two legs, the ratio between the legs of angle ABC is actually AB over AC. Okay, so again, the angle bisector AD divides the side that it is, that is to say, divides angle bisector AD its side BC, so it divides the side BC in a ratio of BD over DC, and that ratio equals to the ratio between the angle legs. The angle legs is AB and AC, and the ratio between the angle legs is AB over AC. So the angle bisector AD divides side BC in a ratio of BD over DC, and that ratio equals to the ratio between the angle legs, that is to say, to AB over AC. Okay, so the angle bisector theorem states that angle bisector AD divides side BC in a ratio of BD over DC, and that ratio equals to the ratio between the angle legs, that is to say, to AB over AC. Okay, so in the next step we'll focus on the right triangle, triangle ABE, on the right triangle, triangle ABE. AD is angle bisector. AD is angle bisector. Again, in the right triangle, triangle ABE, AD is angle bisector. Okay, in the right triangle ABE, AD is angle bisector. Why AD is angle bisector in the right triangle ABE? Because of the fact that AD divides angle BAE to two equal parts, to alpha and alpha. Therefore, AD is angle bisector in the right triangle ABE. And according to the angle bisector theorem, the ratio that angle bisector divides BE is BD over DE, and that ratio equals to the ratio of angle sides, to the ratio of AB over AE, AB over AE. Okay, so according to angle bisector theorem, in triangle, the right triangle ABE, we have angle bisector AD. Therefore, the angle bisector AD divides side BE in a ratio of BD over DE, and that ratio equals to the ratio of the angle legs, that is to say, to the ratio of AB over AE. Okay, so what is the size of BD? BD equals to 3 units. To 3 units, it is given us in the question, and DE equals to 4 units. So in total we got that BD equals to 3, DE equals to 4. So actually AB over AE equals to 3 over 4. Okay? AB over AE equals to 3 over 4. And we will define AB as 3K. AB equals to 3K according to our definition, and we will find out the value of AE. What is the value of AE if AB equals to 3K? We will substitute AB by 3K and we will find out the value of AE. Okay, so we will get that AB, so AB is 3K over AE equals to 3 over 4. Okay, so we got this equality that (3K over AE equals to 3 over 4), and we will multiply this equality by AE, and we will get that 3K equals to 3 over 4 times AE. In the next step we will multiply this equality by 4, and we will get that 4 times AE equals to 4 times 3K is 12K. Here we will divide this equality by 3 in order to get the value of AE, and we will get that AE equals to 12 over 3 is 4K. So we actually found out that if AB equals to 3K, then AE must be equal to 4K. Okay, so we will continue to focus on the right triangle ABE. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars in the right triangle ABE. That is to say, AB square plus BE square equals to AE square. Okay, so in the right triangle ABE, according to the Pythagorean theorem, AP square plus BE square equals to AE square. So we know that AB equals to 3K. We have already found out that AB equals to 3K, so we will substitute AB by 3K. We will get that is 3K squared. What is the value of BE? BE equals to 3 plus 4, that is to say to 7. So BE square is 7 squared equals to AE square. We have already found out that AE equals to 4K, so AE square will be equal to 4K square. Okay, so we have this equality. So here 3K square is actually 9K square plus 7 square is 49 equals to 4K square is 16K square. So here we will subtract from this equality 9K square, and we will get that 49 equals to 16k minus 9k. 16k square minus 9k square is 7k square. Here we will divide this equality by 7 and we will get that k square equals to 7. We will take a root out of this equality and we will get that k equals to root 7. Actually k equals to the positive root of 7 because k is the size of the side of the triangle. It must be a positive number. So we found out that k equals to root 7, to positive root 7, and we know that AB equals to 3k, AE equals to 4k, and k equals to root 7. So we actually can substitute k by root 7 because k equals to root 7. So AB will be equal to 3 times root 7. And AE equals to 4 times root 7. Okay, so we actually found out the values of AE and AB. So in the next step we will focus on the right triangle ABC. We know that in the right triangle ABC, the right big triangle ABC, tangents 3 alpha equals to BC over AB. Again, tangents 3 alpha equals to BC over AB. But what is the value of BC? BC equals to 3 plus 4 plus x. So BC equals to 3 plus 4 is 7 plus x. So we can write that BC equals to 7 plus x. And we have already found out that AB equals to 3 times root 7. So in total we found out that the value of tangents 3 alpha equals to 7 plus x over 3 times root 7. Okay? So in the next step, we will focus on the right triangle ABE. So in the right triangle ABE, we know that tangents 2 theta tangents 2 alpha equals to BE over AB. BE over AB. Again, in the right triangle ABE, we know that tangents 2 alpha equals to BE over AB. Okay? But what is the value of BE? BE equals to 3 plus 4. That is to say to 7 over AB. We have already found out that AB equals to 3 times root 7. So in total we found out that tangent 2 alpha equals to 7 over 3 times root 7. So I write it down. Tangent 2 alpha equals to 7 over 3 times root 7, and we have already found out that tangent 3 alpha equals to 7 plus x over 3 times root 7. So in the next step we will focus on the right triangle, triangle ABD. So on the right triangle, triangle ABD, we know that tangent alpha equals to BD over AB. Okay, on the right triangle, triangle ABD, we know that tangent alpha equals to BD over AB. But what is the value of BD? BD equals to 3 units. It is given us in the question. And we have already found out that AB equals to 3 times root 7. Okay, so tangent alpha equals to 3 over 3 times root 7. So I write here that tangent alpha equals to 3 over 3 times root 7. So we actually found out the values of tangent alpha, tangent 2 alpha, and tangent 3 alpha. And we also know that tangent 3 alpha equals to tangent 2 alpha plus alpha. Okay, tangent 3 alpha equals to tangent 2 alpha plus alpha. And in order to find out the value of tangent 2 alpha plus alpha, we will use trigonometric identity. The trigonometric identity is tangent A plus B equals to tangent A plus tangent B over 1 minus tangent A times tangent B. Again, tangent A plus B equals to tangent A plus tangent B over 1 minus tangent A times tangent B. So we will use this trigonometric identity in order to find out the value of tangent 2 alpha plus alpha. So we will actually have here tangent 3 alpha equals to tangent 2 alpha plus alpha, and the value of tangent 2 alpha plus alpha according to this trigonometric identity will be tangent 2 alpha plus tangent alpha over 1 minus tangent 2 alpha times tangent alpha. Okay, that is the value of tangent 2 alpha plus alpha according to this trigonometric identity. But we have already found out the values of tangents alpha, tangents 2 alpha, and tangents 3 alpha. So we will substitute the values of tangents alpha, tangents 2 alpha, and tangents 3 alpha in this equality by the values that we found out for the tangents alpha, tangents 2 alpha, and tangents 3 alpha. So we will get that tangents alpha actually equals, according to what we have already found out, tangents 3 alpha actually equals to 7 plus x over 3 times root 7. That equals to tangents 2 alpha. The value of tangents 2 alpha is 7 over 3 times root 7 plus tangents alpha. The value of tangents alpha is 3 over 3 times root 7, all divided by 1 minus tangents alpha times tangents beta. That is to say, to 7 over 3 times root 7 times 3 over 3 times root 7. Okay, so we got this trigonometric identity. So here, in order to have a common factor with this expression, we will substitute 1 by 3 times root 7 times 3 times root 7 over 3 times root 7 times 3 times root 7. Okay? So we will get that 7 plus x over 3 times root 7 equals to, in the numerator we have 3 times 7 over 3 times root 7 actually here 7 plus 3 is 10, so it is actually 10 over 3 times root 7, all divided by, as I have already said, we will substitute 1 by 3 times root 7 times 3 times root 7 over 3 times root 7 times 3 times root 7. As you can see, actually this expression equals to 1. So we substituted 1 by this expression in order to have a common factor with this expression. Okay? So, and here we have 3 times 7 is 21. So in total we got this equality. Here we will move this expression to the numerator and we will move this expression to the denominator here. Okay, and we will get that 7 plus x over 3 times root 7 equals to 10, and we will move this expression to the numerator, so it is 10 times 3 times root 7 times 3 times root 7 over 3 times root 7, and we will move this expression to the denominator here. That is 3 times root 7, 3 times root 7 minus 21. Okay, so we got this equality. So here we actually have 3 times root 7 in the numerator, and we have 3 times root 7 in the denominator, so we will cancel 3 times root 7, and what is left after we cancel 3 times root 7 is 7 plus x over 3 times root 7 equals to, here 10 times 3 is 30, so it is 30 times root 7 over, here actually 3 times 3 is 9, and root 7 times root 7 is 7, and 9 times 7 is 63. So it is 63 minus 21. Okay, so we have this equality. We know that 60, here is 21, I forgot the 1, 21. So here we know that 63 minus 21 is 42, so I write it down. We have 7 plus x over 3 times root 7 equals to 30 times root 7 over 42. So we have this expression. Here we will multiply this equality by 3 times root 7, and we will get that 7 plus x equals to 3 times root 7 times 30 times root 7 over 30 over 42. So here 3 times 3 is 9, and root 7, 3 times 30, 3 times 30 is 90, and root 7 times root 7 is 7, and 90 times 7 is 630. So we have 630 over 42 equals to 7 plus x. Okay? $630 over 42 is 15. So 15 equals to 7 plus x. So here we will subtract from this equality 7, and we will get that x equals to 15 minus 7, 8. So x equals to 8 units. That is the answer to the question, that x equals to 8 units. So here the value of x is 8 units. Actually 8x that equals to AC equals to 8 units. Okay, x that equals to EC equals to 8 units. That was the answer to the question. That was, we finished with method 1. So in the next step we will find out the value of x according to the second method. And we will make a construction here. We will extend side BD by 3 units. So we extended side BD by 3 units. We will define this point as point M. We extended side BD by 3 units, therefore MB will be equal to 3 units. That is according to our construction. And then we join together points A and M by a straight line. Okay, so we have here triangle A and B. Actually, we extended BD by a straight line, so MDM is a straight line. Because we extended the straight line BD by 3 units, so MD will be also a straight line. So MD is a straight line. MD is a straight line. And we have a rule that states that the sum of the angles on a straight line is equal to 180 degrees. So the rule states that the sum of the angles on a straight line is equal to 180 degrees. I will read the rule again. The rule states that the sum of the angles on a straight line is equal to 180 degrees, and we know that MD is a straight line. Okay, we know that MD is a straight line, therefore the sum of the angles on the straight line MD equals to 180 degrees according to the rule that I presented to you, to this rule. So if we focus at point B, the sum of the angles on the straight line MD at point B must be equal to 180 degrees. So which angles we have at point B? We have actually angle ABD is a right angle. It is given us in the question, so it equals to 90 degrees plus the size of angle ABM must be equal to 180 degrees according to the rule that I presented to you. According to this rule, on the straight line MD at point B, the sum of the angles must be equal to 180 degrees. So at point B we have 90 degrees and angle ABM, so the sum of those angles must be equal to 180 degrees according to this rule. So here we will subtract 90 degrees from this equality, and we will get that the size of angle ABM is equal to 180 degrees minus 90 degrees is 90 degrees. So angle ABM is a right angle, that is to say it equals to 90 degrees. So here we know that angle ABM is a right angle. Okay, so in the next step we will prove that those two triangles can go into each other. So we will focus on those two triangles, on triangle ABM, the right triangle, triangle ABM, and the right triangle, triangle ABD. So we will focus on those two right triangles and we will prove that they can go into each other. First of all, we know that MB that equals to 3 units equals to BD that also equals to 3 units according to our construction. MB equals to 3 units and it equals to BD that also equals to 3 units. So MB equals to BD that equals to 3 units. And we also know that those two angles are equal to each other, they are both right angles. So actually angle ABD, that is a right angle, equals to angle ABM, that is also a right angle, that equals to 90 degrees. Angle ABM equals to 90 degrees according to what we have already proved. We have already proved that angle ABM is a right angle. So angle ABD equals to angle ABM equals to 90 degrees. And we also have here a common side, AB equals to AB. AB is a common side, it belongs to both triangles. So AB equals to AB. It is actually a common side. Okay, so we actually proved that triangle ABM is congruent to triangle ABD according to side angle side rule. Okay, triangle, the right triangle, triangle ABM, congruent, this is the sign of congruent, to the right triangle, triangle ABD, according to side angle side rule. So what is side angle side rule? If you prove that two sides and the angle between those two sides in one triangle are equal to two sides and the angle between them on the other triangle, then those two triangles will be congruent to each other according to side angle side rule. And we proved that two sides and the angle between those two sides in triangle ABD are equal to two sides and the angle between them on triangle ABM. Therefore we proved that those two triangles can go into each other according to side angle side rule. Okay, so from the fact that those two triangles can go into each other, we can conclude that those two angles are also equal to each other. That is to say, angle BAD in triangle ABD, the right triangle ABD, angle ABD, angle BAD in triangle ABD, angle BAD equals to angle BAM according to the rule that corresponding angles in congruent triangles are equal to each other. Okay, corresponding angles in congruent triangles are equal to each other. Again, angle BAD equals to angle BAM according to the rule that corresponding angles in congruent triangles are equal to each other. Actually, those two triangles can go into each other, therefore the corresponding angles, those two corresponding angles, will be also equal to each other. And we know that angle ABD equals to alpha, angle ABD equals to alpha, so from this equality we can derive that angle BAM also equals to alpha. Angle BAM also equals to alpha. And we can conclude from the fact that those two triangles can go into each other that actually side AM of triangle AMB equals to side AD of triangle ABD. Those two sides are equal to each other. I'll write it down. AM equals to AD. So AM equals to AD according to the rule that corresponding sides in congruent triangles are equal to each other. Corresponding sides in congruent triangles are equal to each other. Again, AM equals to AD according to the rule that corresponding sides in congruent triangles are equal to each other. Actually, those two triangles can go into each other, therefore the corresponding sides, that is to say AM and AD, will be also equal to each other. And if we define AM as Y, then AD that equals to AM will be also equal to Y. Okay, so if AM equals to Y, then AD will be also equal to Y. So AM equals to Y and AD also equals to Y. So in the next step we will focus on triangle ADC. So on triangle ADC, or in triangle ADC, so in triangle ADC, we know that AE is angle bisector. AE is angle bisector. Again, in triangle ADC, AE is angle bisector. why AE is angle bisector in triangle ADC? Because of the fact that AE divides angle DAC to two equal parts, to alpha and alpha. Therefore, AE is angle bisector in triangle ADC. And according to the rule of the angle bisector theorem, AE divides the side DC in a ratio of the angle's legs. So AE divides DC in a ratio of DE over EC, and that ratio equals to the ratio between the angle's legs, and then the ratio between angle's legs is AD over AC. Okay, so according to angle bisector theorem, AE divides the side that it eats, that is to say the side B, AE divides the side DC in a ratio of DE over EC, and that ratio equals to the ratio between the angle's legs, and the ratio between the angle's legs is AD over AC. AD over AC. So the ratio that AE divides the side of DC is DE and over EC, and that ratio equals to the ratio between the angle's legs, that is to say to AD over AC. Okay, that is according to angle bisector theorem. And what is the value of DE? DE equals to 4 units, according to what is given us in the question. What is the value of EC? EC equals to X, that is also given us in the question, that EC equals to X, that is the value that we want to find out in this lecture. And what is the size of AD? AD equals to Y according to our definition, so it is Y over AC. So in total, we got this equation number 1, that X over 4 over X equals to Y over AC. Here we will multiply equation number 1 by AC, and we will get that four over X times AC equals to Y. We will multiply equation number 1 by X, and we will get that 4 times AC equals to Y times X, four times AC equals to Y times X. Here we will divide equation number 1 by 4 in order to get the value of AC. So we will get that the value of AC according to equation number 1 is actually Y times X over 4. Okay? So in the next step, we will focus on the big triangle, triangle AMC. So on the big triangle, triangle AMC, actually AD is angle bisector in triangle AMC. AD is angle bisector. again, AD is angle bisector in the big triangle, triangle AMC. Why AD is angle bisector? Because of the fact that AD divides angle AMC to two equal parts. Here we have alpha plus alpha, 2 alpha, and also we have here alpha plus alpha, 2 alpha. So AD, the angle bisector AD, divides the angle AMC to two equal parts, 2 alpha and 2 alpha. Therefore AD is angle bisector in triangle AMC. And according to the angle bisector rule or angle bisector theorem, AD divides side MC in a ratio of MD over DC. MD over DC, and that ratio equals to the ratio between the angle legs. And the angle legs are AM and AC. So AM over AC is the ratio between the angle legs. Again, according to angle bisector AD is angle bisector in triangle AMC. So according to angle bisector theorem, the angle bisector AD divides side MC in a ratio of MD over DC, and that ratio equals to the ratio between the angle legs, and the angle legs of angle MAC is AM and AC. Those are the two angle legs, AM and AC. So the ratio between the angle legs is AM over AC, and that ratio equals to the ratio that angle bisector AD divides MC. Okay? So, what is the value of MD? The value of MD is actually 3 plus 3, that is to say 6. And what is the value of DC? DC equals to 4 plus X. What is the value of AM? The value of AM is actually Y. According to our definition, the value of AM is Y. So it is Y over AC. So in total, we got equation number 2 that states that 6 over 4 plus X equals to Y over AC. So here we will multiply equation number 2 by AC, and we will get that Y equals to 6 over 4 plus X times AC. So here we will multiply equation number 2 by 4 plus X. And we will get that 6 times AC equals to Y times 4 plus X. Okay, so here we will divide equation number 2 by 6 in order to get the value of AC. We will get that the value of AC equals to actually Y times 4 plus X over 6. That is equation number 2. And according to equation number 1, the value of AC is actually Y times X over 4. Okay, so we have the value of AC in equation number 2 and equation number 1. So in the next step we will create equation number 3 that states that AC equals to AC AC equals to AC, and we'll substitute here the AC here by the value of AC in equation number 1, and on the other side of the equality we will substitute AC by the value of AC according to equation number 2. Okay, and we will get that AC according to equation number 1 is y times x over 4, and AC according to equation number 2 is y times 4 plus x over 6. So we got this equality. Here we will divide this equality by y. It is allowable to divide this equality, the equation number 3, by y, because y can never be 0. Y is the size of a side in a triangle, therefore it must be a positive number and it can never be 0, therefore it is allowable to divide this equality by y. So after we divide this equality by y, we will get that x over 4 equals to 4 plus x over 6. Here actually the value of AC is actually, okay, x over 4 equals to 4 plus x over 6. Okay, so here we multiply this equality by 6 and by 4, and we will get that 6x equals to 4 times 4 plus x. We will open the brackets here, and we will get that 6x equals to 4 times 4 is 16 plus 4x. We will subtract 4x from this equation number 3, and we will get that 2x equals to 16. Here we will divide this equality by 2, and we will get that x equals to 8 units. So we found out that x equals to 8 units. X equals to 8 units according to method 2. According to the second method, x that equals to EC equals to 8 units. So we finished to find out the value of x according to method 2. Now I will summarize the lecture. Actually, we wanted to find out the value of x we know that a triangle ABC is a right triangle. BD equals to 3 units, DE equals to 4 units, angle BAD equals to alpha, angle DAE equals to alpha, and angle EAC also equals to alpha, and we want to find out the value of EC. Okay, the value of EC that is defined as x. Okay, so I presented to you the angle bisector theorem, and the angle bisector theorem states that if we have a triangle ABC and AD is angle bisector, why AD is angle bisector? Because it bisects angle BAC, it divides angle BAC to two equal parts, that is to say to theta and theta. Therefore AD is angle bisector, and according to angle bisector theorem, an angle bisector divides the side that it eats in a ratio that equal to the ratio of the angle legs. So the angle bisector AD divides the side that it eats, that is to say AD eats BC. Therefore the angle bisector AD divides the side BC. Actually, angle bisector AD divides the side BC in a ratio of BD over DC. BD over DC, and according to angle bisector theorem, that ratio, that is to say that ratio that is BD over DC, equals to the ratio between the angle legs, and the legs of angle BAC is AB and AC. So the ratio between those two legs is the ratio that angle bisector AD divides BC. That is to say DB over DC equals to AB over AC, that is the ratio between the angle legs, the angle sides of angle legs. Again, the ratio that angle AD divides BC, that is to say BD over DC, equals to the ratio between the angle legs, and the angle legs, the ratio between the angle legs is AB over AC. So DB over DC equals to AB over AC. The ratio that angle bisector AD divides BC is BD over DC, and that ratio equals to the ratio of the angle. That ratio equals to the ratio that the ratio between the angle legs. And the ratio between the angle legs is AB over AC. Okay, so the ratio that angle AD divides BC is BD over DC, and the ratio between the angle legs is AB over AC, and according to angle bisector theorem, that two ratios are equal to each other. That is to say BD over DC equals to AB over AC. Okay? So that is the angle bisector theorem, and then we focus on the right triangle, triangle ABE. On the right triangle, triangle ABE, AD is angle bisector. Why AD is angle bisector? Because it bisects angle BAE. It divides angle BAE to two equal parts, alpha and alpha. Therefore AD is angle bisector in the right triangle ABE. And according to angle bisector theorem, the ratio that angle bisector AD divides the side BE is BD over DE. Okay, the ratio that angle bisector AD divides BE is BD over DE, and that ratio equals to the ratio between the angle legs, and the ratio between the angle legs is AB over AE. AB over AE. So the ratio that angle bisector AD divides DE is BD over DE, and that ratio equals to the ratio between the angle's legs, that is to say to AB over AE. And what is BD? BD equals to 3 units and D equals to 4 units. So in total we got that AB over AE equals to 3 over 4. And then we defined AB as 3K, that is to say AB equals to 3K. So we substituted in this equality AB by 3K, and we found out that the value of AE, if AB equals to 3K, then the value of AE equals to 4K. Okay? So we know that AB equals to 3K, AE equals to 4K. So we continue to focus on the right triangle, triangle ABE, and on the right triangle, triangle ABE, according to the Pythagoras theorem, the square of the hypotenuse equal to the sum of the squares of the perpendiculars. That is to say, AB square plus BE square equals to AE square. We know that AB equals to 3K, so AB square is 3K square. BE, the value of BE is actually 3 plus 4, that is to say 7. So BE square is 7 square. And we have already found out that AE equals to 4K, so AE square is 4K square. So we solved this simple equality and we found that K equals to root 7. After we found that K equals to root 7, we can find out the values of AB, that is 3K, and the value of AE is 4K. So if K equals to root 7 and AB equals to 3K, then AB actually equals to 3 times root 7, and AE that equals to 4K will be equal to 4 times root 7. Okay? Then we focused on the right triangle, triangle ABC. In the right triangle, triangle ABC, we know that tangents 3 alpha equals to BC over AB. Okay, tangents 3 alpha in the right triangle ABC equals to BC over AB. But what is the value of BC? BC actually equals to 3 plus 4, that is 7 plus x. That is to say BC equals to 7 plus x. BC equals to 7 plus x, and we have already found out that AB equals to 3 times root 7. In total, tangents 3 alpha equals to 7 plus x over 3 times root 7. Then we focus on the right triangle, triangle ABE. On the right triangle, triangle ABE, we know that tangents 2 alpha equals to BE over AB. Okay, tangents 2 alpha in the right triangle ABE equals to BE over AB. What is the value of BE? BE equals to 3 plus 4, that is to say to 7. So BE equals to 7, and we have already found out that AB equals to 3 times root 7. So in total, we found that tangents 2 alpha equals to 7 over 3 times root 7. And then we focused on the right triangle, triangle ABD. On the right triangle, triangle ABD, we know that tangents alpha equals to BD over AB. Okay, tangents alpha equals to BD over AB. But we know that BD equals to 3 and AB equals to 3 over 7 over 3 times 3 over 3 times root 7. So in total we found that tangents alpha equals to 3 over 3 times root 7. Okay, so we actually found out the values of tangents 3 alpha, tangents 2 alpha, and tangents alpha. Then we also know that tangents 3 alpha equals to tangents 2 alpha plus alpha, yes? And in order to calculate the value of tangents 2 alpha plus alpha, we have this trigonometric identity that tangents A plus B equals to tangents A plus tangents B over 1 minus tangents A times tangents B. So we use this trigonometric identity in order to find out the value of tangents 2 alpha plus alpha. Actually, tangents 2 alpha plus alpha according to this trigonometric identity equals to tangents 2 alpha plus tangents alpha over 1 minus tangents 2 alpha times tangents alpha. And we substituted the value of tangents 3 alpha by 7 plus x over 3 times root 7. We substitute the value of tangents alpha by 3 plus x over 3 times root 7. We substituted the value of tangents 2 alpha by 7 over 3 times root 7, and we substituted the value of tangent alpha by 3 over 3 times root 7 in this equality, and we got to this equality after we substituted the value of tangent alpha, tangent 2 alpha, and tangent 3 alpha, and we actually solved this simple equality that is actually one equality with only one variable, that is x. And after we solved this simple equality, we found out that the value of x is actually 8 units. The value of x is 8 units. That is to say, EC that equals to x equals to 8 units. That was the solution according to method number 1. Then we found out the value of x according to the second method. According to the second method, we actually made a construction. We extended side BD by 3 units, and then we defined this point as point M. Therefore MB is equals to 3 units because we built it like that. Okay, so MB equals to 3 units. Then we join together points M and A by a straight line, and actually MD is a straight line. MD is a straight line because we extended the straight line BD by 3 units, therefore it's still a straight line. So MD is a straight line, and according to the rule that the sum of the angles on a straight line equals to 180 degrees, we know that the sum of the angles on the straight line MD equals to 180 degrees. And especially at point B, the sum of the angles on the straight line MD must be equal to 180 degrees. And so what we have at point B, we have this angle that is 90 degrees plus the size of angle ABM must be equal to 180 degrees Again, on the straight line MD at point B, the sum of the angles must be equal to 180 degrees according to this rule. That is to say, this angle that is 90 degrees, it is given us in the question, plus the size of this angle that is actually angle ABM must be equal to 180 degrees according to this rule. We subtracted from this equality 90 degrees, and we found out that the size of angle ABM is 90 degrees. That is to say, this angle is a right angle. Then we proved that those two triangles can go into each other. Those two right triangles can go into each other. Why they can go into each other? Because MB equals to BD equals to 3 units. MB equals to 3 units according to our construction. So MB equals to BD equals to 3 units. And also we know that those two angles are equal to each other, but they both equals to 90 degrees. That is to say, angle ABD equals to angle ABM equals to 90 degrees, and AB equals to AB. AB is the common side, it belongs to both triangles. So we actually proved that triangle ABM can go into triangle ABD according to side angle side rule. What is side angle side rule? If you prove that two sides and the angle between them on one triangle are equal to two sides and the angle between them on the other triangle, then you proved that those two triangles can go into each other according to side angle side rule. And we proved that two sides and the angle between them on triangle ABD equals to two sides and the angle between them on triangle ABM. Therefore we proved that those two triangles can go into each other according to side angle side rule. So for the fact that those two triangles can go into each other, we can conclude that those two angles are also equal to each other according to the rule that corresponding angles in congruent triangles are equal to each other. Those two triangles can go into each other, therefore the corresponding angles must be also equal to each other. And if this angle is alpha, this angle must be also equal to alpha because those two angles are equal to each other. Okay, so angle BAD equals to angle BAM equals to alpha. And we defined AEM, and we can also conclude from the fact that those two triangles can go into each other that AEM equals to AD. Why? According to the rule that corresponding sides in congruent triangles are equal to each other. Actually, those two triangles can go into each other, therefore the corresponding sides, that is to say AM and AD, must be also equal to each other. So AM equals to AD, and if we define AM as Y, then AD must be also equal to Y because they are equal to each other. Okay, so AM equals to AD equals to Y. Then we focused on triangle ADC. On triangle ADC, we know that AE is angle bisector. YAE is angle bisector on triangle ADC because AE divides angle DAC to two equal parts. That is to say, to alpha and alpha. Therefore, AE is angle bisector in triangle DAC. And according to the angle bisector theorem, AE divides side DC in a ratio. What is the ratio that AE divides side DC? The ratio is DE over EC. The ratio that angle bisector AE divides side DC is DE over EC. Okay, that is the ratio that angle bisector AE divides side DC, and that ratio equals to the ratio between the angle sides. The ratio between the angle sides is AD over AC. AD over AC equals to DE over AC according to angle bisector theorem. The ratio that angle bisector AE divides DC is DE over EC, and that ratio equals to the ratio between the angle sides, and the ratio between the angle sides is AD over AC. So that two ratios are equal to each other. So what is the size of DE? DE equals to 4. DE equals to 4. What is the size of EC? EC equals to X. So EC equals to X. AD equals to Y. So AD equals to Y. So in total we got that 4 over X equals to Y over AC. Here we multiply this equality by AC and we got this equation, and after that we multiply it by X and we got this expression, and then we divide this expression by 4 and we got that AC equals to Y times X over 4. Then we focused on the big triangle AMC. On the big triangle AMC, AD is angle bisector. Why AD is angle bisector in triangle AMC? Because of the fact that AD divides angle AMC to two equal parts, to 2 alpha and 2 alpha. Therefore AD is angle bisector in triangle MAC. And according to angle bisector theorem, the angle bisector AD divides side AC in a ratio. What is the ratio that angle bisector AD divides side MC? The ratio is MD over DC. The ratio is MD over DC. The ratio that angle bisector AD divides side MC is MD over DC, and that ratio equals to the ratio between the angle sides, the angle legs. That is to say, to AM over AC. The ratio that angle bisector AD divides side MC is MD over DC, and that ratio equals to the ratio between the angle legs, that is to say AM over AC. And what is the value of MD? The value of MD is 3 plus 3, that is to say 6. What is the value of DC? DC equals to X. What is the value of DC? DC equals to 4 plus X. DC equals to 4 plus X. And what is the value of AM? AM equals to Y. So in total we got that MD over DC equals to MA over AC is 6 over 4 plus X equals to Y over AC. We multiply this equality by Y by AC, and we got that Y equals to 6 over 4 plus X times AC. We multiplied this equality by 4 plus X, we got this equality, and then we divided this equality by 6, and we got that the value of AC according to equation number 2 is Y times 4 plus X over 6. And we have already found out that in equation number 1 that AC equals to Y times X over 4. So we have the value of AC in equation number 2 and also in equation number 1. Then we created equation number 3 that states that AC equals to AC, and we substituted the value of AC in this side of the equality by the value of AC in equation number 1, and we substituted the value of AC on the other side of the equation by the value of AC that we found in equation number 2, and we got this equality. We solved this, we divided this equality by Y, and we got this equality, and then we multiplied this equality by 4 and by 6, and we solved this simple equality, and we found out that the value of X is 8 units. Okay, the value of X is 8 units. That is to say EC that equals to X equals to 8 units. So we found out in both methods, in method 1 and method 2, that EC, that is X, equals to 8 units. Okay? Thank you very much.